Hello, good morning, students. Today we are going to discuss the topic cluster analysis from the Unit 3 Efficiency in Business Intelligence. Let's understand what is cluster analysis. It is a statistical method for processing data. It works by organizing items into groups or clusters based on how closely associated they are. So, it is an exploratory data analysis technique which is used to group together the data points that are very similar to each other within a data set. So this method is ideal for identifying patterns and detecting the outliers among unlabeled data. So it is something like a dimensional reduction analysis is concerned with data collection in which all the variables have been associated or partitioned beforehand into criterion versus predictor subsets. So the objective of cluster analysis is to find similar group of subjects where the similarity between each pair of subjects represents unique characteristics of the group versus the larger population or sample. The strong differentiation between the groups is indicated through separate clusters. Sometimes a single cluster indicates extremely homogeneous data. So a cluster analysis is an unsupervised learning algorithm, which means you don't know how many clusters exist in the data before running the model. Unlike many other statistical methods, cluster analysis is typically used when there is no assumption made about the likely relationship within the data. So it is providing information about where the associations and patterns in data exist, but not what those might be or what they mean. So there are different applications of cluster analysis. One of the application is market segmentation, which is used to segment customers based on purchasing behavior and allow the business to send the right offers to the right people. The second application is image segmentation, in which the computer vision can be used to group pixels of an image to detect the objects like human faces, cars, or animals. The other one is biological classification, which is the clustering of scientific process where to group genes with similar behaviors to understand the diseases and treatments. The other kind of application is document classification, which is used to apply in search engines to categorize the web pages for better search results. The last application is anomaly detection. Here the cluster analysis is used for outlier detection to identify rare data points so that do not belong to any clusters. So when it comes to understanding the cluster analysis, it is also known as clustering short form, which groups similar data points forming the clusters. So the goal is to ensure the data points within a cluster are more similar to each other than to those in other clusters. For example, if you take an e-commerce retailers, they use clustering to group the customers based on their purchasing habit. If one group frequently buys fitness gear while another prefers electronics, so this helps companies to give personalized recommendations and improve customer experience. So it is useful for scalability, which means efficiently handle large amounts of data. High dimensionality, which can handle high dimensional data. Adaptability to different data types, which can work with numerical data like age, salary, and categorical data like gender and occupation. Handling noisy and missing data, usually the data sets contain missing values or inconsistencies, and clustering can manage them easily. The interoperability output of clustering is easy to understand and apply in real world scenarios. So the challenges in cluster analysis, while clustering is very useful for analysis, it faces several challenges. Choosing the number of clusters methods like k-means requires user to specify the number of clusters before starting, which can be difficult to guess correctly. The second challenge is scalability, because some algorithms like hierarchical clustering does not scale well with large data sets. The third challenge is cluster shape. Many algorithms assume clusters are round or even shape, which does not always match real world data. Handling noise and outliers also, they are very sensitive to noise and outliers, which can affect the results. So the different types of cluster algorithms are There are different categories are available. One is partition based algorithms, hierarchical algorithms, density based algorithms, grid based algorithms, model based algorithms, constraints based algorithms, and outlier analysis algorithms. So, on a conclusion, in today's data driven world, the sheer volume of available information can be overwhelming. So, this cluster analysis is providing a structure to this chaos by grouping the similar data points together. So, these clusters reveal hidden patterns that would otherwise be missed by traditional linear analysis methods. Such segmentation paves the way for personalized marketing strategies, improved customer service, and optimized product offerings. At its core, clustering simplifies complex data sets by answering questions like which customer groups are most profitable and how can the product recommendations be tailored for different segments and which regions show similar buying patterns that indicate untapped market potential. So these are some examples questions to have a clustering with more perfection. Fine, thank you students. Let us see in the next class.